All right, we're talking about SQL. So by the end of this lesson, I hope that you'll be able to create databases using SQL commands, and I hope you'll be able to query databases using SQL commands. Let's talk about this first one. Creating databases. First thing I want to talk about is the concept of types in databases. This is one of our sanity checks. We can make sure that we're always storing legal data. A lot of like database stuff in general is based around the idea of like, all right, is all of the data that we have legal? And by legal, I mean, does it conform to those relationships? If my event can only have one organizer, do I in fact only have one organizer for that event? Because if I don't, the whole database is suspect at that point. Even smaller level than that, if I'm keeping track of names, those have to be strings or something kind of like that. They can't be numbers. They can't be Booleans. They got to be what we're expecting. And so if we try to put a record in that database, the database goes, not so, and doesn't let you hurt your data. So SQLite, which is the database system that we're going to start with. Anybody know any other database systems?
MongoDB.
MongoDB. MongoDB, actually, let's kind of do like a little family tree here. So we'll say this is databases. Over here is what we'll call relational databases. That's what we're working with. Then we're going to talk about a family of databases largely referred to as NoSQL, one of which is MongoDB. You might have heard of like mean stack. I'm a mean stack developer. I hate that term. So MongoDB is the M in mean stack. What other databases you heard of? Access? Access is relational. What's Access?
That's a Microsoft program.
Yep. It's like their database equivalent to like Word and Excel and those kinds of things. There's like, I've always been a little bit curious who that's for, and I've done a ton of Access database work, but it's like a little bit underpowered for professional work, and I'm not sure who in the office knows how to like work with databases and is also choosing Access, but it's, I don't know, they keep coming out with new editions of it, so somebody's getting it. All right, so Access is Microsoft's beginner one. Anybody know what Microsoft's Pro database is? SQL Server. SQL Server is Microsoft's professional database system. Other database systems you've heard of? MySQL, excellent. MySQL was an open source, I guess it technically still is, open source database system that was purchased by another database company. Anybody know who it is? Oracle, who is one of the last of the giant evil enterprises in tech world, old guard evil enterprises. So Oracle bought MySQL. MySQL is still free, still open source, but that was one of Oracle's attempts to stay relevant because not everyone was buying billion-a-seat database licenses from them. And like, no kidding, I think one of the reasons they did it is to prevent MySQL from coming out with too many cool features. That's how that world works. Since it's open source, that means you can make your own version of it. And somebody did. It's called MariaDB. That's not owned by Oracle. Any other ones you've heard of? Postgres. Postgres is kind of the winner. So towards the end of the program, as we mature a little bit and get past SQLite, which is another relational. We'll probably mostly be working in Postgres. Postgres is also open source, which means you don't have to pay to use it, and you can see the code, and you can write features for it, and all that kind of stuff. It is owned by the people. So Postgres did exactly what Oracle was worried MySQL was going to do, and just came out with one killer enterprise feature after another. And even when like the NoSQL revolution kind of came and went, a lot of the cool things that the NoSQL world came out with are probably better embodied by Postgres now. I think any other ones worth knowing about? MongoDB was the biggest of the NoSQL ones. So in NoSQL, all those relationships that we were just modeling, there aren't any. There's no relationships in NoSQL. What NoSQL has instead is, you know how like hashes can have hashes as their values and have hashes and hashes and hashes all the way down? That's what you store in NoSQL. Store just like these nested trees of things. It's called documents. But NoSQL was a big one. Cassandra was another one. Couch was really popular for a while. What was that? Azure? Azure's a cloud platform. I'm sure there's some database component to that, but that's Microsoft's big cloud play. And the only one that I really see anyone using a ton of anymore is called Redis. And that does a super specific thing. AWS has both relational and NoSQL solutions. Okay, so AWS will let you run SQL Server or Postgres or MySQL or Oracle or something like that on their database servers. And they also have their own. I never remember what it's called, but nobody should use it. It's the cheapest though. And they also have one for NoSQL. I can't remember what it has a cryptic, stupid fucking name. It's management console. Going down a rabbit hole. I want to show you something. I want to show you something cool. All right, so their database stuff is this. RDS is their relational one. DynamoDB is their NoSQL one. And then like within those, let's see, create database. See, we can do any of these. Aurora is their like one that they made up. But you could also just say, I want to use Postgres or MySQL or Oracle or whatever. Pretty cool. Okay, so that's kind of our database landscape. These are ways that we can implement these models that we were talking about. And let's go back to data types. The thing that differentiates a lot of these is the types of data that's allowed. So like all of them will do string-like things or Booleans or numbers. Some of them will let you store different types of numbers. Some of them will specifically let you store things like geographic coordinates or like more complicated types of data like that. So for SQLite, SQLite 3 has very few data types. Text, numeric, integer, real, blob. There you go. You're going to see this word blob a few times when you're looking at databases. Does anybody know what it means? It's an acronym. It stands for binary large object. So if you're storing like pictures, like just literally binary code. And I generally recommend you pretty much never do that. Store like a URL to where that file's being stored. All right, we're going to deal with text and integer. If I want to make a database table, if I want to make a database, I'm going to type SQLite3, and I'm going to call this, let's do library. Library.sql, or .db, yeah, .db. Could be anything, it's just a name. And this is going to dump me into a new terminal-like thing. However, you'll notice if you try to ls or cd or pwd, it's not working. It's because it's not a normal command line. It's a SQL command line. The only commands we can type in here are SQL commands. And the reason that it just keeps going is the way that you end a SQL command is with a semicolon. Someone, before this day is over, before the cock crows 3 times, one of you will forget to put a semicolon something. You'll just keep getting these lines because it all thinks it's part of one command. So the way that we create a table in a database, one of our entities.
Do we need to navigate to a certain directory first?
Nope. So the cool thing about SQLite 3 is it's, if I get out of this, it just makes a file. That file is our database. Most database systems are a lot more complicated than that. One of the reasons SQLite is so nice to start with is that it's not. It's just a file. So I want to make a table for books. So I'm going to type create table books. I'm going to open a parenthesis, a paren. And I'm going to hit enter. I'm still entering the same command. Why am I still entering the same command?
So you put the colon.
No semicolon. So I can say something like, well, the title of the book is text. You don't have to use the capital letters like I'm using here. I think it helps though. We generally use capital letters with things that are like database system specific and lowercase letters for stuff that are just part of our data model. So books, that's not a SQLite 3 thing, that's a MyApp thing, so it's lowercase. The title of the book, that's my thing, so that's lowercase. Text, that's a data type supported by the database system, so it's uppercase. So I can say a book has a title and a page count. And that's an integer. And then I'm going to hit enter. And I'm going to close the paren. I'm going to make that semicolon that I love so much. And then if it doesn't throw an error, I did it correctly. And I can prove that I did it correctly if I type .schema. And if it poops out the thing that I typed in, then it knows. It knows. So what I want you to do is get this far. Throw up a hand if you get stuck. Okay, so you go into some folder. Just close it one. Cool. So, now do SQLite 3. Yeah, space.
Infrequent the comma.
Control D to get out of that. Control D will dump you out of the SQL terminal. So remember we're stuck. Okay, so we're going to do SQL 3 and then the main database.
Oh, I see what you did. You, like for creating tables.
Now you're in that console, and so you're going to try to make this a table.
Yeah, see, look, you typed in SQLite, or then you go.
Other issues. Yeah.
How do you get into back into SQLite? So if I'm in my
Okay, so you're going to do SQLite 3 and then library.
Cause like mine's literally just like create table books and all that. It thinks your function starts right.
Okay. I think it's that dot it doesn't like. So try typing it all out again. Oh, and you also will run the SQLite 3 command inside of SQLite. Any other issues? If you think you got that, see if you can make a an authors table with a first name and a last name.
Do you have to go to a different area to create that, or should I create the same?
You can do it as long as you're back at the SQLite prompt. We can just issue another command.
Say name and age, or
First name, last name.
first and last name.
so each line
Mhm.
is like another column in the table, right?
No. So, yeah, for this. Yeah, these two are columns.
Got it.
Yeah, author and open parentheses. Enter yet. I know this weird. I know. Yeah, exactly. And then yeah, name and last name, first and last name. First and then text, comma, last.
Just to check.
Yeah. Yeah.
Then you guys are going to do first name and last name with that.
Yeah. And enter in closing parentheses, semicolon. To finish it off. This last part, the closing parentheses, the semicolon. Yeah.
Do you have to go to another one?
Yeah, can you put that on the same line if you're ending your, okay.
You can.
Oh, you can put it on the same lines, it works.
Killer.
There you go, got it. Yeah, it is weird, No. It's command line. Oh, there you go.
So, interesting thing from over here, you can also do this all in one line. So I was doing create authors, and then inside of this did first name text, last name text, and just ended it like that. Oops. Create table. Come on, Coverly. Act like you've been here. I can also do that. This format tends to be a lot better once you start getting more and more and more and more columns. And you go, wait a minute, did I leave one out? Cool, so if I look at my schema with a dot schema, that shows those two commands that I use to create tables. They're not related at this point, but they are both in there. And that is creating a database using SQL commands. We have these empty vessels waiting to be filled with precious, precious data.
Is there on some data types and databases, there's like a character limit?
That you have to declare? Yes.
Yeah, or that you're limited by?
Data types will have certain limits. For example, integer is like as many characters as you can store within such and such bits. And then there'll be a big int that's like, if you think the data could exceed that, there's another data type you can use for that. Anybody guess why they would make you make that choice? Smaller what?
Take up less space.
Takes up less space. So usually with these records, if you're saying, all right, this is a big int, the database will allocate all of that space as if it was taking up the most amount of space. So if it's something like I don't know, a salary or something like that, that's not going to have 70 characters behind it. You pick a smaller thing, save some space. It's like, especially nowadays, that stuff's literally commodity. You're just paying more for the extra space. Other questions about anything we did to create databases using SQL commands? Yeah?
Where's the library .db located?
Doesn't matter. You can put it wherever. It's just a file. So on a lot of database systems, it'll be in a special part of your computer and it like runs as a process. This is just a file. You can put it wherever you want.
Is it when you want to access that file, it's not giving any access?
Was that?
You want to access that file you just created?
So it'll do it in whatever directory you're in when you ran the command. So if I type, check this out, I can make another one. So right now I have this one I've just been working on. If I type SQLite3 ben.db, it's going to create that file for me. So when I close that, oops, might have to actually do something with it. Yeah. And I create table programming. Does it actually need me to put stuff in it? Create table, programming, and ID, which is an integer, like that. There we go. So now if I quit this, I have BenDB in that same folder. Other questions about creating databases and tables? Cool. So there are 4 SQL commands that you need to know to be proficient at SQL. They are, in order, insert into, select, update, and delete. These 4 commands, if these are the only 4 SQL commands that you know, you'll probably know about as much as 90% of developers. These are your meat and potatoes, bread and butter, especially select. If you can write a decent select, you can put SQL on your resume and no one will be the wiser because they don't know anymore either. So what I'd like you to do right now, and for the next, let's say 5-6 minutes, I want you to look up the syntax for these 4 commands, write them down in your notes, and then we're going to chat about them. Go! Another minute. All right. So I'm going to call on somebody to tell me about insert into. Think for a sec. Andrew, what you got for me?
So it looks like insert into just literally inserts given information into whatever table you're giving it.
Mhm.
So the syntax would just be like the table name and then all the names of the values
Mhm.
and then the actual values. So like the name, the age, whatever it might be.
Bravo, bravo, bravissimo. So we say insert into, and then do those even read as different colors up there? Yeah. Insert into table name, and then I open a paren, and then what do I put here, Andrew?
Like the value names, like first name, last name.
Sure. Okay, and then I close up that paren. And then what do I say?
And then values and the values of those what do you call them? Variables.
Indeed. So I'm going to say that, and then something like Kyle Coberly. And then how do I end SQL statements?
Semicolon.
Semicolon. Always, always, always. So compared to Ruby, SQL is crazy strict. When you hit enter, that kind of stuff, that doesn't matter at all. But when you use parentheses, when you don't use parentheses, single quotes versus double quotes, that shit makes a big difference. So that's probably where you're going to get tripped up the most on this is little teensy things like that, like what does and doesn't have commas after it. Capitalization not. Doesn't care about capitalization, doesn't care about white space, which is like enters or extra spaces, that kind of stuff, it'll figure out. But these properties here do not have quotes around them. These strings, this text, has single quotes, not double, not backticks.
Even if it's not a string?
No, only if it's text.
So that whole thing could just be one line?
Yep, and you could also jam all this into one line. You do it all uppercase, all lowercase. That part doesn't matter. Questions about insert syntax?
Just for writing references, do you prefer to capitalize all the amount of it that you need?
So if it's part of the database system, like these commands or data types or something like that, the convention is generally all capital letters. If it's something that's related to your app, like these table names or these column names, that's usually all lowercase. It makes it easier to visually scan queries and see what's happening. Cool. Questions about insert? Let's insert a value. So if I go into my library database,
Sorry,
Yep.
Do one row at a time.
nope, you can do multiple rows. So what you do is you put a comma here and then open up another paren and just keep doing that. You put as many as you want. Let's try that. So I go over to the library and I'm trying to add me and Elise into as authors. So I'm going to say insert into what? Authors. Okay. And then I'm going to open up a paren. I want to add our first names and our last names. I need to specify that because you don't have to insert into every single column, and you can insert them into whatever order you want. You're saying that this is the order I want to do these inserts in. All right, and then values, Kyle. Oh shoot, is it gonna let me go back? Crap. All right, so I forgot the comma there. I guess I could technically put it in now. Let's see if it'll let me. Comma. So if you do just code yourself into a hole, Control D will kill it. Lets you start over again. All right, so I've got Kyle and Coberly. I'm going to close that, and I'm going to enter in Elise also. So I close the paren, comma, new paren, Elise, Coberly, close that, and then tell it to execute the command. Neat. If it doesn't barf, it probably worked. So now, skipping ahead, if I say select all from authors, hey, there we are. Cool. So in the interest of time, I want to make sure you guys get a chance to take a whack at that code challenge today too. So talk very briefly about these next ones. Select is our most powerful and our most widely used. The structure of it is select what? Column names. So I'll say first name and last name, or you can use star for just everything. Select first name, last name from what? Table name. And then, quite often, we want to constrain this. So this will give us the first name and the last name of every single person in, say, the authors table. I often don't want every single one of them. I want one of them. I want some subset of them. So how do I constrain it? Where? And then I can put some expression here that will narrow this down. So that could be something like first name equals Kyle. That's only going to give me my record back. So I say select, or I can even say just give me the last name. Who is that guy named Kyle? Well, give me last name from authors where first name doesn't even need to be one of the things I'm selecting on. Is Kyle. Cool. Coberly comes back. We can do more than one constraint. How do we do more than one? And. So we can check to see if things are equal. We can also do something that's kind of like searching with the keyword like. And the way that this works, I think is pretty neat. You can say where like last name has an E in it. Those percent signs are like wild cards. So I can leave off the first one. It's like, well, it needs to start with an E. Leave off the last one. It needs to end with an E. Put it on either side. It needs to have an E in it somewhere. So I could say select, not a requirement. And a lot of times when I'm typing out a query like this, I won't bother. It's when I'm saving it in a file that's going to be read. If I'm just typing it into a command line like this, I usually don't bother. All right, give me first name, last name from authors, where first name is Kyle, and oops, I executed it. Shoot. Select first name, last name from authors where first name is Kyle and last name like, and then I can say something like has a Z in it, and I'll get nothing back because there is no match for that. That's selecting. Updating. Somebody tell me the syntax for updating.
Update the table name.
Mm-hmm.
Set column name equal to set value.
Yep.
And then leave notes up where.
In fact, you generally should. So update table name, set, and we can say first name equal to Damon. So these last two SQL commands, update and delete, are dangerous, mighty dangerous. Because if I run this, I put a semicolon at the end of this, what does this do? Everybody's Damon now. Damon said he'd never met another Damon before he met that Damon. Now we're all Damons.
That's gonna be really confusing.
I'm going to say update authors set first name equal to Damon. All right. Hey, what's the authors table look like now? Oops. We're all fucking Damons. Ah! Okay.
Can you undo that?
No, you can't.
Unless you change it back.
Like, but if there was a whole bunch of names and now they're all Damon,
Oh, shoot, yeah.
Good job, dude.
that's why like doing this stuff directly to a database is the scariest shit you'll ever do. I had a bunch of those for Develop Denver where it's like, can you give me, it was like flagging talks as accepted. It's like, okay, so we agreed all these talks were accepted. We don't have a web interface for that where like you just check a box or something. And so I have to go in the database and run the command to like, all right, these 70 talks, mark them as whatever. One fat finger. It's one of those like type really slowly, try to stay away from the semicolon, and you're like read it forwards, read it backwards, and go, and hope you see 76 records updated, not 4,000 or something like that.
Scary.
Incredibly nerve-wracking. And there was a guy, while I was doing that, who was like, I don't like how this is formatted. Let me write a query. I was like, I'm not letting you write a query on my production database, you fucking crazy. So the way that we don't do that with everyone is you put a where constraint on it. Say where last name equals self. That's updating. Deleting works the exact same way. What was the delete syntax? Delete. Before we get to where? Table name.
So if you use update and you don't already have a daemon in your database, does it create one?
So with this one, it's setting every single, well, if we didn't do this, every single first name that already exists is now daemon. And if I add this where clause, it only does it to every record whose last name is self. And if none of them are self, it doesn't do anything.
Okay.
See, and is it delete? I'm pretty sure it was delete from. Delete from table name, and then where. Otherwise, what do you think it does?
Deletes everything.
Everything. Delete from table name where ID equals 3 or something like that. So yeah, if I do delete from authors, how many authors I got now? I got none authors. So I can insert into authors first name, last name, values, Kyle, Coberly. Cool. I'm going to do that with Elise. Hey, where are my authors at? All right, we're back in there. Now. I want to delete Elise.
Oh,
Dangerous.
very grim. Gotta delete her.
So, delete my wife. This sounds like a really shitty, like, top 40 song.
Delete my.
All right, delete from authors where first name equals Elise. Now, show me the authors. Just me.
Roll
So, those are our queries. Let's zoom back a little bit. Metaphorically and literally.
Yeah, let's just say
I've got a Ruby app. Remember when I was making Bixby and I was making Mesa, we were doing the dog park thing, and then I would kill the application? And then what would happen when I started again?
they weren't there anymore.
No dogs. I'd have to create them every single time. That file, that database, what if, instead of relying on me typing it out every time, when I create a new dog, it inserts it into the database. And when I fire up the app, it does a select query to get all of the dogs. And that's what populates my dogs list. That's why we're doing this. So we have our Ruby app, and we have our database. That's the symbol for database, by the way. And these two talk to each other. I can kill this app. I can boot it up. I can kill it. I can boot it up. The data lives separately. It doesn't shut down and get started up. Data at rest, data in motion. Pretty cool, Kyle. That is querying databases using SQL commands. What questions have you about SQL and databases?
Why would you use a MySQL?
So, it's a great question. The way that we tend to use data in applications is nested. So we have this little hierarchy. Think about Hashketball, that big game hash we were working with. It's not just Ruby. Most programming data structures tend to kind of look like this. Databases, relational databases, store those flat. And so you have something that's like A has a reference to B, B has a reference to C, C is standalone. And so we use this flat structure to kind of recreate this nested structure. This is called relational. This is called object style. These two don't really have like that good of a one-to-one correlation. So we call this the object relational impedance mismatch. That's your big vocabulary word that no one will ever give a shit that you know. Trust me. So this impedance mismatch means that when we store stuff from our app to the database, we need to take these nested structures and make them flat. When we get things out of the database, we need to take these flat things and make them nested. That has a non-zero cost to it, and it's also very constricting as far as how we model things. So NoSQL, any guesses how we store our data in NoSQL? Just like this. You take this nested data structure and then you store it that way, and then you take it out that way. Document style. So there are more challenges that are worth talking about today as to like why that ultimately was pretty roundly rejected by the software community. It still has a place. I really like it for options and configuration and anything where the specific keys that you're going to have can change a lot over time, ultimately don't matter that much, and it's more of a pain in the ass to model out how all of those things work than is really worthwhile. Like the joke, but yeah, kind of not a joke, slogan for NoSQL has always been, for when it positively, absolutely doesn't have to work. And that last NoSQL solution that I told you is still kind of around, Redis. Redis doesn't have nesting. Redis is just key value. It's like a hash that only goes one level deep, always. Because it turns out it's super hard to maintain this nested hierarchy and data integrity. That thing I was talking about at the beginning about types and all that sort of shit, how you know that there is not two organizers for an event. NoSQL turns out doesn't have a great way of enforcing that. And so it's mega easy to corrupt your data. Cool. Other questions about SQL and databases? Cool, thank you. Go and be merry.